let's keep talking about these crazy inequality things, and let's bump it up a level, and we'll talk about this compound inequalities. Now, let's. If you're wondering what is this, how does this work? Think about compound words, right? It's like when you take two words and put it together, like like backpack, right? So it's back and your pack, and so it becomes a backpack. That would be a compound word, right? So this is the same idea. We're going to have inequalities. We're going to have two inequalities, and we're going to bump them and put them together and talk about them at the same time. So you might say, okay, how does that apply? So the first thing I could think of is a teenager. Maybe this applies to your life a little bit. Maybe you are a teenager. Maybe you're not quite there yet. But a teenager is a definition, and it, by definition, is actually a compound inequality, okay? Because it's between two things. So let's define a teenager as being T. Now, in order to be a teenager, you need to be 13 or older. So the day you turn 13, you become a teenager, right? So if your age is greater than 13 or equal to 13, you are a teenager. However, you stop being a teenager the day you turn 20, right? You go from 19 to 20. Teen is not in your age anymore. You are no longer a teenager. So as long as you are older than 13, right? You're 13 or older. Or what happens is if your age is under 20, right? But not equal to, because if it's equal to 20, you're not a teenager. So the day before you turn 20, you're still a teenager. The moment that day starts, you are no longer a teenager, okay? So that would be a compound inequality because in order to be a teenager, you must be older than 13 and younger than 20. So it falls into two things. Now, when you have a compound inequality using the word and, what we will often do is we will take these two, okay? We'll take, in fact, let me just move the word. We're going to take these two things and we're going to put them together. So you end up with T being between, right? It's greater than 13 and between 20. So let's pick an age that you might be a teenager. Let's say 15. And we'll say, does 15 actually work? Does this actually make sense? Well, 15 is greater than 13, and 15 is less than 20. So 15 is both greater than 13 and it's less than 20. Okay, it has to meet both. It has to meet both criteria. Okay, it has to be more than 13 or equal to 13. And it has to be less than 20. So you could pick it. Let's try another number. You could pick a number that's bigger than 13, maybe 40. Okay, let's say 40. Well, 40 is bigger than 13, but it is not less than 20. So that only meets one of the two criteria. So that means it's out, because when it's and, it means both criteria must be met. Okay, hopefully that makes a little bit of sense. So let's take a look at what we do with these. Okay, so here is a compound inequality. I've just already written it for you, and what we're going to do is we're just going to sort of practice what does this mean and what numbers actually fit there, and then what does this look like when you put it on a number line. So in this case, let's go ahead and read it. We have -2 is less than x, which is less than 3. So you ask yourself, is this an and? Well, you should say yes, because that's the only one you've learned so far. If it's not an and, there's another one called an or. Okay, an or compound inequality, and we'll get to that one in a second. But this one is an and because it two requirements it has, right? One, this number has to be between -2 and 3. Well, if it's between a number, that means it has to be bigger than one and less than the other. So let's first take a look at this. Is it possible? Could I have a number in here that is both bigger than -2 and less than 3? And the answer is yes, you can have some numbers, okay? And the reason I say that is sometimes what you'll do is when we work these, people will do things and they'll say something like, okay, they'll switch the numbers around, right? They'll say -3 and 2. And so you're saying here is there's a number that is bigger than -3. Oops, that's not what I meant to do. Sorry, let me fix that. That's going to work, and I don't want it to work. So you're going to say, I have a number that's, say, bigger than 3 and less than -2. Notice all I did, I put this number over here and this number here. But if you look at this, what number is both bigger than 3 and bigger than -2? there is nothing that, or I'm sorry, and lower than negative 2. You can't have a number that's bigger than 3 and lower than negative 2. This is impossible, right? Impossible. You could say no solution. All right. Be careful how you do that. Here's another very common mistake people will say. Okay, they'll get to the end and they'll say, okay, they'll have, let's say, 4 and 7. And so what this is saying is I have a number that is greater than 7 and it's greater than 4. Well, if it's greater than 7, it's automatically greater than 4. This part isn't necessary, right? So just be very careful about how you write your inequalities and really try to make sense of it. Okay, look at this and say, this is a number. Can this number be both bigger than negative 2 and be less than 3? Okay, try to pick some numbers and get them to work. All right, so let's see what this thing looks like on a number line. Okay, so what we're going to do is I can break this up into two things. I could say negative 2, okay, with x, and x is less than 3. And what we'll do is I'm going to go ahead and this part right here, we'll turn it blue, and the other part we'll graph in red. Okay, so the first one we'll do in red. X is greater than negative 2. Okay, so here's negative 2, and it's going to be greater than that. So I'm going to put an open circle, all right, and then I'm going to shade to the right. Okay, so that is x is greater than negative 2. Now, in purple, or in blue, or whatever this color is, I can't really see it on my board, x is less than 3. Okay, well, let's put 3 here. Okay, and we can try to have 0 in the middle. A lot of times I like to put 0 in there just so that I make sure that my negative is here and 3 is here, and just to give it some perspective. So I'm going to say x is less than 3. Okay, well, it's an open circle, and then what I'm going to do is I'm going to shade to the left. Okay, and what I'm looking for here is I'm looking for the numbers where these things overlap. Okay, so because where they overlap is going to be where they are, where they overlap is going to be the and, where both qualifications are met. Now notice the purple, right? This could be a number, any number that's less than 3. That could be like negative 1 million. Well, negative 1 million is below 3, but it is not above negative 2. That's those purple ones or blue ones over on this end, okay? These numbers, which are bigger than negative 2, could be positive 1 million, right? Well, that works here, but it doesn't work here. And what we're doing is we're graphing the solutions to both. So we can go ahead, whoops, that's not an eraser. We can go ahead and we can get rid of that part. And actually what I'm going to do is I'm going to phase out that. And we'll go here. And then we'll go ahead and I'll just do it in red. Is open circle, and we shade everything in between. Okay? So that's what that one looks like. That's another example of an and. So let's take a look at one where it's an or. Okay, same numbers. I just sort of flipped it around. And so this time I'm going to look at it. And this is just going to be two separate events here. Okay, so I'm going to look at, we'll do this one in red, and then we'll do the other one in blue. Okay, so I've got x is greater than or equal to 3. Okay, so that's a number that's greater than 3. Okay, or I can pick a number that's less than negative 2. So one of the things you can do when you think of or statements is that the or statements are the opposite of and. So and is things that meet two requirements. Or is where only one of them meets. You only need one of them to be true. And so oftentimes what you're doing here is you're saying what things are not. So in fact, let's go back here. This would kind of be like, this is to say this thing here is what does it mean to be a teenager? Okay. Well, I could also say what does it mean to not be a teenager? Okay. Well, that would be if your age, right? In fact, what we'll do here instead, we'll say A for age. If your age is less than 13, or your age is greater than or equal to 20. So it's sort of saying this, in this case, the or is when you're not this. All right. So let's go back here and we're going to do this. So let's say we'll put 3 here. We'll put a closed circle in. In fact, I don't need it. We'll do close. Oops, wrong color. Still the wrong color. There it is. And then we'll shade to the right, okay? Now that means any number that's greater than or equal to 3. Now let's talk about numbers that are less than or equal to, oh, I'm sorry, not equal to, less than -2. So put in -2 here, and I'm going to put in an open circle, and I'm going to say the numbers that are lower than that, and that's going to shade that way. Let me throw in 0. Okay? And again, we're just showing this. Now this is not to scale, right? Because these are equally apart. This is 3, -2. It's just to kind of give you a general sense of what it looks like. Okay, so now we look at this and we say, okay, where can this happen? Well, let's see. If I pick a number that is lower than -2, -4, is -4 greater than -3? No. Or is it less than -2? Yes. So if yes is your answer for one of the two here, right? So here, -4, no. Here, -4, yes. Okay, if I get yes for either one of them, okay, or even both, then my answer works, okay? Then it is part of the solution. If let's say I pick 0, is 0 greater than or equal to 3? No. Is 0 less than or equal to or less than -2? 0? No. So no, 0 is not part of the solution, which should make sense because it's not even in the graph here. Okay? This is the part that's left out. All right. Now, we're going to get some equations here. Right? Not equations, but we're going to get compound inequalities that are going to have some math involved in it. And so let's go ahead and solve this. Now, it's just like all of the other things we were doing. You're going to use additive inverses. You're going to use multiplicative inverses. If you are using a multiplicative inverse that's negative, you're going to have to flip signs around. Okay, like this is going to go from less than to greater than, which you should automatically see here since this is a negative coefficient. It's going to happen. So let's use my additive inverse first here. Okay, so I'm going to have to add a -4. Let's do this in. Okay. All right, so I'm going to add a -4. Now, when I do this, I need to do this to each segment of the inequality. So I'm going to add -4 here, and I'm going to add a -4 over there. Okay, each segment. So I'm going to get 8 is greater than or equal to -2x, which is greater than -2. Now, go ahead, divide by -2, divide by -2, divide by -2. I divided everything by -2. Signs flip. Okay, and I'm going to get 1x -4. And this is why you have to flip them. Notice this went from a positive to a negative. If they were the other way around, this thing wouldn't work. Okay, in fact, let's see. If it was x is, what number is less than 4 and bigger than 1? Right, so you see this is impossible. If it's bigger than 1, it can't be lower than -4. Okay? All right, so then we look at this and we say, okay, well, what numbers are lower than 1 and bigger than -4? Now, let's say you don't like the signs being this way. Okay, so what we can do is I can take this whole thing and flip it around. So instead, I'm going to say -4, and I'm going to keep the less than, right? It's less than or equal to x. And x is less than 1. Now maybe it's a little easier to look at because then I can put in -4, I can put in 1, I'll put in 0 just for good measure. I'm going to put in a closed circle because it could be equal to 4. I'm going to shade over and I'm going to open circle 1 because it can't quite get to 1. And there I have it. Okay, so hopefully you have a little bit better idea of how to do this. On Monday in class, you'll do some practice. And yeah, hopefully it makes a little more sense.